Hey everybody, welcome back. This lesson is on connecting graphs and equations of linear functions. And so we're really building on our knowledge of y equals mx plus b and what that means in terms of slope and y-intercept and x-intercept and whether it's positive or negative. And so just a reminder, linear functions model many different situations in everyday life where the rate of change is proportional. For example, linear function can be used to determine the cost of different quantities of gas or the height of a plant over time. Recognizing whether a graph represents a linear function and its equation can help you make predictions from data. Key concepts: the quantities described by a linear relationship are represented by a linear function, which is a function that can be written in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is the slope. So we've got m is the slope of the line and b is the y-intercept. And remember, when you're identifying the slope and the y-intercept, you're going to look at the sign of the number that comes before it, because that will determine whether it's positive or negative. A function is a relation in which every element of the domain is paired with exactly one element of the range. For every value of x, there's exactly one value of y. A function may begin with y equals or f of x equals, depending on the notation used. Remember, y and f of x are the same thing. The slope of the line is the measure of the rate of change of one variable with respect to another. Slope can be described as rise over run, and the formula for calculating slope is m equals y2 minus y1, and there should be a fraction here, over x2 minus x1. And remember, when you have points, two pairs of points, so let's just make up some numbers here, 5 and 6. And -4 and -2. Our first point, x1, y1, x2, y2. So when you're figuring out which numbers to plug into that formula, you label your pairs of points. So you always have two pairs of points. The first pair are your ones and your second pair are your twos. The y-intercept of a line is the y value where the line crosses the y-axis. So that is b. The y-intercept in any equation that's set up as y equals mx plus b is the b. It's the constant that is comes after the plus sign. It also could be after a minus sign. It could be y equals mx minus b if it was a negative y-intercept. The graph of a linear function is a line that passes through the point 0, b and has a slope of m. Notice that when x equals 0, the equation becomes y equals m times 0 plus b, which simplifies because m times 0, or anything times 0, is 0, to y equals b. The equation for the graph of a linear function can be determined by finding the slope and identifying the y-intercept from the graph. So we're really building on the last lesson where we found the intercepts to be able to determine the graph. So, for example, the linear function graph on the next slide has a rise of 2 and a run of 4. So, remember, rise is your top number and run is your bottom number. Rise can go up and down. If it's positive or negative, positive's up, negative's down. And run can go left or right. If it's left, it's a negative. If it's right, it's positive. You always will want to simplify too. So that's why in this sentence, 2/4 equals 1/2, because 2/4 simplifies to 1/2. The line passes through the point 0, 3. So the y-intercept is 3. Remember, whenever you have a value of 0 for x and a value for y, that means that's the y-intercept. It's where the line crosses the y-axis. Therefore, because we know we have a slope of 1/2 and a b, which is the y-intercept of 3, we can plug those into the equation y equals mx plus b to get this guy right here. Y equals 1/2 x. Why did we use 1/2? Because 1/2 is the slope and 3 is the y-intercept. Okay, So here we go. This is the graph that we were just working off of. So we've got our y-intercept right here at 0 and then 1, 2, 3. So 0, 3. So once you have your y-intercept, now we have figured out what our slope is. Slope was 1/2. So up 1 over 2. Up 1 over 2. Up 1 over 2. So you can also do it the other way. So we've got over 2, up 1, over 2, up 1, over 2, up 1. They also did it. Let me clear the text. 2/4. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. 1, 2. So that's if you didn't simplify. Stick to the simpler when you're doing rise over run, stick to the simplified version because it's going to be easier to graph. If you don't know the y-intercept, the equation of a line can be found either by using 1 point in the slope or by using 2 points. To find the equation of a linear function using a point, which is x1 or y1, and the slope, you substitute the point and the slope into something that's called the point-slope form. This is new. This is a new formula that you have to memorize. You will not be given this. You'll have to memorize your point-slope form and your y-intercept form and your slope formula. And I'll go over all of those at the end of this lesson just to make sure that you've got them all chunked up in your brain. But when you're doing any kind of math with slope, you're always going to need to be searching for something, whether it's an intercept, whether it's slope, whether it's points to be able to graph. So to find the equation from 2 points, you use the 2 points to find the slope first. Then you substitute either the 2 points and the slope into the point-slope form and solve for y. And I know that's a lot of words and it doesn't make any sense, and we're going to go over it right now together, so don't freak out. If 3 points of a function are known and the slopes between the points are different, meaning the points do not fall in the same line, that means the graph is not a linear function. A linear function can still be used as a model when points do not fall exactly on a line, but only if the points show a linear pattern. So common errors and misconceptions are incorrectly choosing the values of the indicated interval to estimate the rate of change, incorrectly estimating the values for the indicated interval, or substituting incorrect values into the slope formula. And we'll go over what those mean just in a second. All right, so here we go. There's your y-intercept of 7/3. No way we could have known that if we didn't actually do the algebra. You cannot just estimate what your intercepts are unless it's a perfectly plotted point. Okay, so the y-intercept is determined from this equation. We already just said that. We looked back at the graph. This equation is in slope-intercept form. Y equals mx plus b, where m is the slope. Remember, m is the slope and b is the y-intercept. So we are donezo. You can turn your y-intercept, which 7/3 is an improper fraction. We can turn it into a mixed number so that we can more accurately see where it is. We know it's going to fall between number 2 and 3. So that's approximately 2 1/3. So this verifies the slope-intercept form of the equation. You guys rock.